Hello everyone, welcome to my medical statistics class. I'm King from the School of Public Health, Department of Statistics. Now, let's start a new chapter. We will learn a new method of hypothesis test, which is called chi-square test. We have mentioned that in the last hour. Here, this symbol is a Greek character. It's not X in English. We call it chi in Greek. So this symbol sounds chi-square. So in chapter 8, what we need to learn is a method called chi-square test. We have previously noted that data may frequently take different forms. For example, in chapter 1, we have mentioned that we can divide the data into different types. For example, numerical data, categorical data, and ordinal data. And we said that for numerical data, for the hypothesis test, we can use t-test, z-test, or ANOVA. For the ordinal data, we can use rank sum test. But how can we do with the data of categorical data? When we met a data consisted with categorical data, we need to use the method of chi-square test. Whenever we classify data from a sample into a frequency table, we are reducing the observations to the frequency in each class. So, in this way, we can categorize data that arise either as counts of various kinds of occurrences or as observations from an underlying continuous distribution. So here, in chapter 8, we will develop methods of hypothesis test dealing with data that have been categorized in this manner. So, as what I mentioned just now, this method, what we will learn in chapter 8, is a method of hypothesis test for categorical data. And most oftenly, we use this method to deal with the data listed in a frequency table. So this is what we need to learn in chapter 8. We will learn 3 types of chi-square tests in chapter 8. The first type is chi-square test for R times C contingency table. So what's the meaning of a contingency table? A contingency table is an appropriate way to display data that can be classified by 2 different variables. So that is very special for us because before chapter 8, we have already learned many kinds of methods of hypothesis test. But you may notice that in each method, there will be only one variable, that is the grouping variable. For example, before and after, that is the group of before and group of after a treatment. So we have only one variable for grouping. In ANOVA, we have, for example, we have three treatments: drug A, drug B, and drug C. But we can consider the question as there is some differences between the treatment levels. We have three levels of the treatment: A, B, and C. What are the different drugs? So that means we have only one grouping variable. But what we will learn in chapter 8 is a method used for two variables. And here, one of the two variables is still grouping variables. And the other one, most often, is the results or effectiveness of some treatment. So here, we divided the result of the effectiveness into two or more than two levels. For example, we want to know the effectiveness of a special drug, and we divided the effectiveness into two groups. The first one is the drug is useful. That means the drug can cure the patients. And the second group is the drug is not useful. The drug is not effective. That means the drug cannot cure the patients. So this is one of the two variables in chi-square test. And then how about the other one variable in chi-square test? The other one most often is the grouping variable, just the same as what happened in the other hypothesis test. So in chi-square test, usually we have two variables. The first one represents the effect of the result of different groups, and the other one means the grouping variable. So we want to know if there are any significantly difference on the effectiveness of the drugs between different groups. So here we just use a data of categorical data, that is the effectiveness or results, and we divided this categorical data into different levels. Sometimes there will be two levels, and sometimes there will be more than two levels. So that is what we do in chi-square test. Okay, so most often we list all the numbers in chi-square test in the form of a contingency table. So that means we need to list all the numbers in the contingency table. So if there is a table, that means there must be rows and columns in that table. So most often, one variable is arbitrarily assigned to rows and the other one to the columns. And in general, we denote the number of row classification by R and the number of column classifications by C. So the data may be presented in an R times C contingency table with R rows and C columns. But please notice that R means the row, and we said that most often we use grouping variable as the row. So if you have two groups in this table, you will have two rows. But don't forget the total. If there is a total row, your contingency table should be R plus 1 rows. So here the R and C actually means the rows and the columns without the total. So if we use grouping variable as the rows, that means there will be R groups in this study. And similar with that, C means the number of column. And we said that we most often we use effectiveness, for example, as the column variable. And here the number of columns should be the level of the effectiveness. So if we want to know whether the medicine is effective or not, there will be 2 columns. That means C equals to 2, because we have 2 levels. One is the effect, and the other one is not effect. But for the other variables, maybe there will be more than 2 levels. For example, if we use the disease severity as the column variable, and we know that the disease severity can include mild, moderate, and severe. So we have 3 levels. So here C should be equal to 3. If we have 2 groups for drug 1 and drug B, so this will be a 2 times 3 contingency table, because there will be 2 rows, that means 2 groups, and 3 columns, that means 3 levels. Okay, so that is what's the meaning of the contingency table. Here we need to list all the numbers in the contingency table, and the observed number or frequency in the ith row and the jth column is denoted OIJ. So O means observed number, so that is what we have really seen in this study. That is the number of the individuals, what is really happened in this study. I means the ith row, and J means the jth column. So O11 is the observed frequency of the cell in the first row and the first column. O12 is the observed frequency of the cell in the first row and second column. So here is my question. What's the meaning of O43? Yes, that means the observed frequency of the cell in the 4th row and the 3rd column. So that means at least the contingency table will have 4 rows and 3 columns at least, right? Okay, so this is a contingency table. So we can find that this is the row variable. Most often we use grouping variable as the row variable, and here this is the column variable. For example, the effectiveness or the results of the treatment. So we can find that there will be C levels under the column variable. And here there will be R levels, R groups, and the grouping variable. So we call it R times C contingency table. But do not forget, there is still a row, which means the row total. And here, this is the column total. So here is my question. What is the number here? Yes, because this is the total, right? This is the total. So here, oh sorry, I make a mistake. Here this number should be the column total, because this number is the summation of the first column, the summation of all the numbers listed in the first column. So this is the column total for the first column. And here this is the same, the summation for all the numbers listed in the second column. So this is the column total. And here this number is the same, right? It's the row total, and this number should be the summation of all the numbers in this row, in the first row. Okay, so here we can notice that this is a special number in the right corner. We use the little n to represent this number. So what is n? We may think that n means the sample size. Yes, that's right, n is the sample size. But please notice that n is the summation. Let's clean it first. This little n locates in the cross position of the row total and the column total. So n is the summation of all the numbers in the R times C contingency table. So that means n equals to 011 plus 012 plus 01C plus 021 to the last number, ORC. So n is the summation of all the numbers in the R times C table. So here I need you to notice that we call it R times C table, but you can find that this table contains more than R groups and more than C columns, because there is still the first row and the total row and the column row and the total column. So when we are talking about R times C table, actually we means there will be R groups and C levels without the total. Okay, so that is what's the meaning of the contingency table. Okay, so here let's take an example. If there is one actor which represents disease severity, and another factor represents blood group, and in blood group we have 4 levels, that is A, type A, B, O, and AB. And in disease severity we have 3 levels: mild, moderate, or severe. So we will find that we can use the disease severity as the grouping variable, and we can use the blood type as the column variable. So that means the disease severity should be located in the rows, and blood group will be listed in the columns. So we will find that there will be 3 groups and 4 levels. So this should be a 3 times 4 contingency table. So we just need to list all of the 3 groups here in the rows and give the name of the group variable and list all the 4 levels in the column. I mean, all the numbers is listed in the column. And we need to list the name of the column variable. And don't forget the total row and column row. So we can construct the contingency table in this way. So that is not very difficult. But please notice that here we use the disease severity as the grouping variable. So we list these 3 groups in the rows and the other one in the columns. But you can change it. Actually, you can change it. So that means you can use the blood group as the grouping variable. And the other one, disease severity, can used as the column variable. So here we will find it will change to an 4 times 3 contingency table. Right? So other one is okay. Other one is okay. So most oftenly we use the grouping variable as the rows, but in this example we cannot identify which one is the grouping variable. So we can use either one of the 2 as the grouping variable. We can list it in the rows, and the other one should be in the columns. But you can change it. Okay. Next one. In chi-square test, we said that the chi-square test is a method of hypothesis test for categorical data. So here, let's go back to last slide. Let's clean it first. So here, we can compare among these 3 groups. Is there any difference among the 4 blood groups? So that means we need to compare the proportion of each group, the number of each group in the total. So here in chi-square test, the general null hypothesis to be tested by an R times C contingency table is that there is no difference among the classification variables. And we mean that the classification variables is the actually means is there any difference of the column variable among different groups. So that is the H0 in chi-square test. So the alternative hypothesis should be there is significantly difference of column variables among different groups. So that should be the HA. Okay. The analysis of the R times C contingency table entails making a comparison of the observed frequencies to the expected frequencies. When the null hypothesis is true, that means we suppose there is no difference of the column variables among different groups, and then we try to prove it by using the observed frequencies and the expected frequencies. Most often, we use the capital O to represent observed frequency, and the capital E means expected frequency. So this is accomplished by a hypothesis test using the chi-square distribution. Firstly, we need to calculate the frequency that we expect in each cell of the contingency table if the null hypothesis is true. So that means if we suppose there is no difference of the column variable among different groups, how many patients should be in each cell of the contingency table? So for a certain cell with the observed frequency Oij, we can estimate the overall proportion of individuals with the jth characteristic by P equals to Oj divided by the sample size n. And here we use Oj. That means the column total in the row of a special cell. So here we expected Oi, which means the total of the row total, and we expect Oi times P should be equal to its observed frequency. So here the expected frequency, we use Eij to represent the expected frequency for the cell of for the ith row and jth column cell. So the expected frequency Eij in a particular cell is the product of the relevant row total Oi and the relevant column total Oj divided by the overall total n. So that means the expected for a particular cell equals to the row total of this cell times its corresponding column total divided by n, and we said that n is the summation of all the numbers in R times C contingency table. So this is the expected frequency, the formula for expected frequency. And please notice that in some other textbooks they use T to represent the expected frequency. So that is actually, they call it theoretical frequency. So that is the same with the capital E, expected frequency. They are the same, just with a different character. So here, when you read some textbook, if you find a special character which is capital Tij, that means the theoretical frequency, which is the same with expected frequency with the capital E, so they are the same. Here we can find that. Let's clean it. We can find that here, this is the formula for chi-square value. So that is the test statistic which is used in chi-square test, and we can find that this test statistic is actually the difference between observed frequency and expected frequency. And we said that the expected frequency is calculated on the base of H0 is true. So if we found the chi-square value is too large, that means the difference between observed frequency and expected frequency is too large. So that means if H0 is true, actually we cannot get the numbers which is happened in our study, because when H0 is true, the number they should be, that is expected frequency, but the number of expected frequency is too large or too small from the observed frequency. So here, when chi-square is too large, we need to reject H0. But if chi-square value is so small, it's small enough. Let's think about it extremely. For example, when chi-square equals to 0, that means chi-square value is the smallest, that is 0. And when it's 0, that means O equals to E, right? And we saw that E is calculated when H0 is true. And we found O equals to E. That means O is what really happened. E is calculated under the H0 is true. So that means this true thing is really happened in this study. So we cannot reject H0. So that is what we will do in chi-square test. So here we have mentioned how to calculate the expected frequency. Okay, let's take an example. You can read it by yourself. Okay, I think you have finished by reading this. Here, in this question, all the numbers are given in the question. But first one, we need to construct the contingency table. So you need to list all the variables and its corresponding numbers in the contingency table. Please notice that in our examination, if I give you a question about chi-square test, I will show you the question in this way without the contingency table. So you need to learn how to construct the contingency table. So here, let's analyze the information which is given in the question. in a clinical survey, 215 patients were collected. So that means there are 215 patients are included in this research. So here, this number means the sample size. That means the little n. No matter how many groups in this group, in this question, no matter how many levels in this research, the whole sample size is 215. So that means the little n in the right corner of the frequency table is 215. And then we can find that of which 164 patients have taken digitally, and that is a drug. And 51 patients haven't taken it. So that means we divided all the patients into two groups. The first one is who take the medicine, and the second one is who didn't take the medicine. So here we can know that actually in this contingency table there should be two rows, because we can find that there are two groups. So we can list it here with the drug and without the drug. That means they don't take the medicine. And we can find that the total patients for which group is 164. So that means this is the total 164, and the total for without group is 51. So we have already known the total. And next one, each of them receive an ECG examination. The results are listed in the following table. Here some numbers are given in the table, but in our examination I will give you all the numbers in this sentence and ask you to construct the contingency table. But no matter how many levels are listed in the contingency table, we have already known by our analysis, we know that there are two groups, and the total and the sample size is 215. Okay, so here this is the contingency table. So we can find that with and without groups. And here is the row total and the total sample size. That proves we are right? Okay, so here we can find that this is the ECG, the results of ECG. That is the column variable, and we can find that there are two levels in this variable. The first one is normal. The second one is with some special disease. So here we divided the patients into these two results level, and this is the observed frequencies listed in the contingency table. And now, although I haven't given you all the numbers in the question, but I think if I give you the some informations about the numbers in these two levels, you can list all the numbers in the contingency table, right? Okay, so here let's think about the null hypothesis and the alternative hypothesis. I have mentioned that in category test, the H0 should be there is no difference of frequency distribution between the two groups. So that is actually means there is no difference of the column variables between the two groups. So HA is there is significant difference between the two groups, and alpha significance level is still two-sided 0.05, and we said that you can omit two-sided because in our medical statistic we don't talk about the question about the one-sided test. Okay, here this is how can we get the formula of chi-square value. So here in general we use characters to represent the numbers which is given in the contingency table. So here we can find that in this table we have 2 rows and 2 columns. That means in the grouping variable we divided out the sample size into 2 groups, and for the column variable we have 2 levels, which is C1 and C2. So here we use A to represent 011, B represent 012. So 021 is C, 022 is D, and then we can find that we can use these simple characters to calculate all the data in this contingency table. So here the total of the first row is A plus B, and the total for the second row is C plus D, and the column total for the first column is A plus C, and the second column total is B plus D, and the sample size little n equals to A plus B plus C plus D. We don't use 011, 012, OIJ here because that is too complex. And here let's calculate the proportion of C1 in each group. So we can find that in group 1, that is the first row. In group 1, if we want to calculate the proportion for C1, that means we need to use the number of 011, which is A divided by its total, A plus B. So this is the proportion for C1 in group 1. The same with that, C1 proportion for group 2 should be C divided by C plus D. So here, if we forget the 2 groups, we just consider that all the individuals are in the same group. That is the total group. That means we have A plus C patients for C1 level, and B plus D for C2 level, and there are n patients in this group, and we can find that the C1 proportion should be A plus C and then divided by n. Is that right? Okay, so here this is what we have mentioned just now. This is the formula for expected frequency. The expected frequency can be calculated by using this formula. So now I will explain how can we get this formula. Let's learn it. We have mentioned that the expected frequency is the expected the EIJ is the expected frequency for OIJ when H0 is true. So that means, do you know what is H0? We said that H0 is there is no significant difference between the 2 groups. So that means the proportion for C1 in group 1 and group 2, they are the same, right? And then in mathematics we will find that if the proportion 1 and proportion 2 they are the same, we will find that the total proportion must be the same too. So these three numbers they are the same. But do not forget that this same thing is based on H0 is true. So that means if these three numbers are not the same, H0 must be wrong, must be false. Okay, now if H0, we suppose H0 is true, and then we will find that these three numbers are the same. So that means we can use either one of the three to represent the other two. So that means we can use the total proportion to represent proportion for row 1 and row 2. Okay, so now let's think about it. If H0 is really true, that means proportion of group 1 and proportion of the total, they are the same. So we can use P as the proportion. So this is P, this is P2. All of the three numbers are equal to P. So here, if we use P times the total of group 1, what can we get? Actually, we can get, if P equals to A divided by A plus B, we can get A, right? And we said that A is OIJ, the observed frequency. But if H0 is really true, and we said that P equals to A plus C divided by N. So here we will find that this number should be equal to A plus C times A plus B divided by N, right? And this number is what we called it EIJ, expected frequency, because it's based on P equal to A plus C divided by N. And this is based on H0 is true. So that means this is the expected frequency. That is what that is not really happened in our research. So here, if we can prove that the observed frequency A really equals to this number, that means we prove that H0 is really true. Okay, so here is how can we get the formula for expected frequency. So we will find that here A plus B is the row total for cell 1 for 011, and here A plus C is the column total for 011. So generally we can find that expected frequency for each cell can be calculated with this formula: the cell's row total and the cell's corresponding column total divided by the sample size little n. So that is how we can get the expected frequency. And then we can use this formula to calculate the chi-square value. Okay, so next class we will go on to talk about the chi-square value formula and how to use that formula to do the chi-square test. That's all for today's class. See you next class.